Okay, if you have the complete document, you notice the document's pretty long, by the way. And over here, right now it's saying get 900 pages. Document last updated the 3rd of April, 2024. And I'm going to go to the last page and scroll over here. And I want to do a problem I haven't done yet at the whiteboard. And it's this one over here. All right, so I'm going to go to the whiteboard. Let me see if I can open up a whiteboard for you. And let me just see where the whiteboard is, right over here. I'm going to delete this one, our prior problem. And then let me go back to my question over here. So it says that this symbol over here is the greatest integer function. There's a footnote 142. If you read that, computer scientists often refer to this as the floor function. It states the greatest integer. This is another symbol that's used for it. I actually prefer this symbol over here. However, other symbols are used. I notice in most calculus books, they use the symbol that I have presented the problem. What it goes, it says the greatest integer not larger than x. In the C language, it's referred to as just the floor. I like the floor function as well, by the way. There's another footnote over there, 143. And 143 says this is from the American High School Mathematics Examination. And these are like, they're my understanding, they're given, or they were once given massively to high school students that showed promise in mathematics. And I guess at some schools it was, a large number of students were taking this exam, by the way. And what they would do is they'd sift through the exam, and it's a long exam, by the way, and they'd see how the students did on it. Now, some of them were selected for taking more difficult exams and moving towards the International Mathematics Olympiad, all right? But anyway, it's a question I saw on one of the tests from, I think it was from 1983, actually. 1986, all right? I will go to the whiteboard, I'll write it down. And the way I'm gonna write that down is just look at the question, and I know they want a sum, all right? And the sum is gonna be from k equals 1. Let me get my pen. Let me get black ink. So k equals 1 off to 1,024. And it's going to be the floor function. I'm going to use this symbol over here, log base 2 of k. All right? And certainly the worst thing you could do is to write down 1,024 terms and get your calculator and start to compute the numbers. So the first thing I thought about, how's this log function behaving over the integers from 1 to 1,024? Well, it's going to jump. It's going to be 0. It's going to jump to 1. It's a floor function. 2, 3, 4, 5, 6. And again, I'm looking at this part over here. 7, 8, 9, 10. Now, you may wonder why I'm stopping at 10. Let me just go through that with you. Log base 2 of 1024. And this can be log base 2 of, 2 to the 10th power. Let me make sure I understand that. 2 times 2 is 4, 8, 16, 32, 64, 128, 256, 512, 1024. What happens over here? This is 10 log base 2 of 2. Well, log base 2 of 2 is just 1. So this number is just 10 over here. And what's the floor of 10? It's just 10. And it's stopping at 10. Now, why am I starting at 0? Well, let me go through that. If I start log base 2 of 1, all right, that's where we're starting 1. And someone says, what's that going to be? Well, 2 to what power would be 1? That would be 0. What's the floor of 0 is 0. And then it goes to 1, and then to 2, then to 3, then to 4, then to 5. Now, the question is, when does it jump to 1? All right, when does it jump to 1? Well, at 2 to the 1. And when does it jump to 2? At 2 to the 2. When does it jump to 3? At 2 to the 3. When does it jump to 4? At 2 to the 4. When does it jump to 5? I think you get the idea. 2 to the 5, 2 to the 6, 2 to 7, 2 to the 8, 2 to the 9, and 2 to the 10. All right? Now you have to start to realize that this is a counting problem now. And the count is going to be how many of these things are there. All right? So what I want to do is talk about, if I looked at this thing over here, and I would write down 1, 2, 3, 4, yada, 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 all the way up to 1024. All right? I want to point out the 0. By the way, this is 2 to the 0. And this is 2 to the 1. All right? And this is going to be 2 to the 2 over here. Now, if I keep doing this over here, 8 would be 2 cubed. all right? So what I'll point out over here, the 0, right? It's going to be, let's see. I got to do this, right? It's going to be, how many are there going to be? There's just going to be one of them. So it's going to be 2 to the first power minus 2 to the 0. All right? Let me just point out what I just did there. This 0, it's going to occur one time, and I'm just doing a subtraction to figure how many there are. I'm going to do the next thing up, and the next one's going to be 1. All right? So let's put that down, because we're at 2 now. So it's going to be 1. And that's going to be, looking at it, it's going to be 2 to the 2 minus 2 to the 1. All right? Where am I getting this from? Go back to my pen, get my highlighter out. I'm looking at this thing over here. So, this will produce a 1, this will produce a 1. And then I'm kind of moving over here, so forth and so on. Let's put the next one down. The next one's going to be 2. And then what do you get? Well, you get 2 cubed, it's right over here, by the way, minus 2 squared. Now, by the way, this is where sometimes I start to think, am I writing down the right thing? And just kind of looking at it, 2 to the 1 minus 2 to the 0 is 1. There's 1, 0. 2 to the 2 minus 2 is 2. Well, there's going to be 2 1s. I'm seeing that. And let's just check this out over here, all right? So we're just doing this thing over here. And I know, 2 to the 8th gives me 3. So really I'm at 7 now, all right? So how many terms? 4, 5, 6, 7. There's 4 terms over there. Well, this gives me 4, all right? It seems like there's a reason. So I'm going to put ... And then I'm going to say the last one, wow, that's a tough one, isn't it? So this is 2 to the 10, and I'm at 2 to the 9 now, all right? By the way, there's only going to be one of these. But now the question is, what do you get this over here? And that's going to be, a 9. Let's think about that, all right? So I'm going to say it's going to be 2 to the 10 minus 2 to the 9, and then we get a 110 over here, just one of them. All right, let me just show you where I'm seeing a pattern over here. All right, but there's only 110. All right, now this is the summation, and this is really what we're trying to figure out over here. And what's S equal to? S is equal to K equals 1 to 1024 of the floor log base 2 of K. Now, whoops. I want to add that together, but I'm looking at this. I did it again. I'm so used to writing those symbols down. It's a floor. I'm looking at this thing over here, and this is the part I'm kind of worried about over here. So I'm going to keep writing this thing down, S, and S is equal to, well, the first term's just 0. And then I'm looking at this thing over here, and I want to kind of like write this down, and I'm going to get, 1 times 2 to the 2 minus 1 times 2 to the 1. All right, this one's done. Let's write the next one down. What do you get there? You get 2 times 2 cubed minus 2 times 2 squared. What's the next one going to be? 3. It's not that bad to write down, actually. And then, 4. Let me put 3 over here, too. Let me put these down, too. So 2, 4, 2, 3. 2, 5. And 2, 4. All right, yada, yada, yada. I get to the end of it, and the end of it's going to be that 9. And that's going to be 2 to the 10 minus 9, 2 to the 9. Right, what comes, and these are all added together, by the way. Put this down. The last term is just going to be a 10. All right, looks like a difficult summation. Now, what's before the 9? It's going to be 8 times 2 to the 9 minus 8 times 2 to the 8th. All right? What I start to notice about this over here, from looking at this over here, I notice it's what's called a telescoping series. And by telescope, what I'm talking about is that these successive terms are going to be canceling off, but not totally. Now, what do they cancel to? Let's take a look at the first one. The first one, just looking at it, I am getting one of the terms. I'm getting, minus 1 times 2 to the first power. That's this guy right over here. There's a loner. But now I'm looking at these two. And what does this give me? It gives me minus 1, 2 squared. All right, let's go to the next one. What's the next one going to be? It looks like I get minus 1, right? 2 cubed. Well, I think you get the idea now. And this is going to be minus 1, 2, 4, minus 1, 2, 5. Going backwards, what do you get? Minus 1, 2, 9. I hope you realize the 8 would cancel out and everything in between would cancel out. So I'm going to do my yada, yada, yada. I am going to stop at minus, let's write this down now. Let's see, 1 times 2 to the 9th power. Now, where's that coming from? Right over here. However, I'm left with this. And what's that? Plus 9 times 2 to the 10th plus 10. All right, this is what I'm worried about now, not the end, all right? Not the end. I want to factor out the minus 1. And what do you get there? 2 minus 2 squared minus 2 cubed. Oh, you know what? It's plus, because I'm going to minus 1. Let me put this down. Yada, 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 up to 2 to the 9th power. And this one over here, oh boy, that's going to be a tough one, isn't it? So it's 9 times 2 to the 10th plus 10. Let's not worry so much about that, all right? I want to do this, though. And certainly I want to talk about adding that together. So I'm just going to call it, let's call it, I don't know, let's call it lowercase s. That's going to be 2 plus 2 squared, yada, 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 up to 2 ninths. It is geometric, though. Multiply it by 2. What do you get over there? 2 squared, 2 cubed, plus yada, 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 up to 210. I'm going to subtract these. Well, 2s minus s is just s. Well, I got to subtract the other guy. What are you going to get? 2 to the 10th. That's right over there. 2 to the 9th would cancel off, and everything down to 2 squared would cancel off, minus 2. So I could write that down now. Let's put that down. What are you going to get? Minus 1. That's going to be 2 to the 10th, minus 2, plus 9, 2 to the 10th, plus 10. Again, it is arithmetic, and I want to point out, a lot of people struggle with arithmetic, and hopefully I'm not going to struggle too much. And look at this thing over here. This is going to be minus 2 to the 10th, plus 2, plus 9, times 2 to the 10th, plus 10. All right? Okay, I'm looking at this thing, and I'm starting to realize that I could combine these two terms together. It's minus 1 and 9, which is going to be 8 times 2 to the 10th power. All right? And then what do you have here? 2 and 10 is plus 12. All right? Now, I got to do arithmetic now. So 8 times 2 to the 10. And remember, 2 to 10 is 1,000, is 1,024. Again, 2 times 2 is 4, 8, 16, 32, 64, 128, 256, 512, 1024. Let's do this. 8 times 4 is 32. 8 times 2 is 16. That's going to be 19 now. And then 8 times 0 is 0. And I get 8. Subtract 12. And what do you get there? 8180. All right? So the thing about this one over here, again, arithmetic mistakes can happen. And certainly when you're on a competitive exam, I want to point out that I think I made a mistake somewhere too. The reason I'm looking at my answer key and it's not the same answer. So I'm wondering where I made a mistake, which brings me back to a point. On a competitive exam, people do make mistakes, by the way, but they do look at your work and they wonder that you make a trivial error or a serious one. Let me erase this scratch work over here. And let me just see if I think I made a mistake in my arithmetic. Let me go back over it again. I think I made a mistake over here. So that's 1,024 times 8. 8 times 4 is 32. 19. Oh, you know what? I subtracted. Now I'm seeing it. It's plus 12. I subtracted 12. This is incorrect. Let's put this down. 4, 10. I'm adding 12 to it. 2, 8204. All right? So let me go back over that again. On a competitive exam, what they're looking for. They're looking for you to write work down. It's sort of readable, by the way. Now, granted, someone says, what's over here? I don't know if I could read that. Sometimes on a very serious competitive exam, they have advocates that actually know the student and will say, oh, this is what the student's doing over here, and they'll talk to the grade. They're actually advocate for the student. That's when you're at the upper end of the scale, by the way. And then over here, bottom line, I'm going to say I did write some things down over here. How important that is, by the way. And then I kind of put a little bit more work down here. But I'm going to be honest with you, this is probably the critical step in the problem right over here, being able to realize I get this summation over here. The next thing up is, realizing I got a telescoping series and doing that. And I did get this result over here. It took me some time, by the way. But I'm going to say the critical step over here would be something like this. Understand you got a geometric sum over here. And the final answer, 8,204. Final answer. We are done. Thank you.